Thanks so much, Neil, and to all you guys for coming out. So just to set the floor for me, get a sense of where everyone's coming from, how many of you have heard of Data Skeptic? I didn't say ask if you liked it, just who's heard of it. All right, cool. So a few hands down to give you a quick synopsis. Oh, excuse me. That'd get cut out on the live show, or on the edited show. We're a weekly podcast. You can find us on iTunes, Stitcher, all those sorts of places, or at dataskeptic.com, but don't go till January. Site's messed up. And we do topics in and around data science, so machine learning, stats, AI, that kind of thing. We tend to take on themes or seasons or whatever you want to call it. So last year we did about 6 months on artificial intelligence, followed by 6 months on fake news. And this year I got really lucky. We switched to the topic of natural language processing in January, and this has been an absolutely historic time for that field, so I got lucky with that. And come this upcoming January, we're going to talk all about model interpretability, and this is a little preview, not widely known. So mainly we're an interview show, and I'm going to bring up 2 guests in a little bit, but how many people were here yesterday for the sort of more hands-on workshop day? All right, good. I'm glad so many people were. I was a little jealous of how much hands-on stuff was going on, and walking around, I saw so many laptops open not to Outlook, but to Sublime or Atom or VS Code, and I was like, well, okay, we should really do something legit here to kick off the show, especially since I have a visual. By the way, listeners, this is what I look like. So under the topic of serverless, another show of hands, who has never heard of or does not know what serverless is? Don't be shy. All right, we got a couple. Serverless is kind of self-explanatory. It's software that need not have a server. The best example, or the canonical one, is Lambda functions, and I think AWS was the first people to put that out. Basic idea of a Lambda function, and I'll show you some in the little intro here. It's where you give your code to a service provider, in that case AWS, but all the clouds have them, and they will run that code for you under certain circumstances. So a classic example is you upload a image to your S3 bucket or your Azure Blob Store or whatever the case may be, and you'd like to have a thumbnail of that. You don't need to bog your web server down with that or even worry about having a good pool of computers, because what if you get bursty traffic? The offering of serverless is, hey, every time an image shows up, we'll just run this function and charge you a very tiny bit of money for each run, and you'll get your magical little thumbnail showing up all the time. Scaling, a lot of the problems that data people don't like to work on get pushed off to the cloud provider. Serverless has come a long way, and I was kind of lucky to attach my horse to it early on for some of our client projects and especially our internal work. So the demo I want to put together right now is really going to be a little bit live coding, mainly meant to emphasize how easy this has become, and I'll spare you the how it was uphill both ways when I got going. Let's see, let's pop into a good directory here. There's an application I'm going to show you guys called Chalice, or I guess it's a framework. It's from AWS, but I think it might be open source. There are lots of projects like this. Zappa is another Python one. We use Claudia, JS, and Node, and if you go Google serverless framework, there's probably been 2 released today. So in the case of Chalice, you do Chalice, I think, new project, blah, 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 and that has created a directory for you. And inside are 2 files, a requirements file that I take for granted everyone here knows about, and a pretty simple app file. And then 2 really magic commands. The first one, Chalice local, is going to run that on a little local web server. And for all the Flask people, this is very Flask inspired. So when we pull that up, we get the hello world. All right, that's on my local drive, great. Also nice for active reloads, so let's open that up and just change that hello. And it's rebuilt, and we get our exclamation points. Okay, local, wonderful. Now, my favorite part, Chalice deploy for the built-in CI/CD. It's going to create an IAM role for you and do all the stuff that is kind of perplexing when you start with the cloud, and really just tries to wrap things up in a nice way and make it kind of easy for people who are already comfortable with something like Flask. So here our deployment is done. I've been given an endpoint. By the way, this is a public endpoint, so you guys can hit this if You need to know how hello the world is today. But actually, as I was working on this, I thought, you know what? Why don't we try and make it something a little bit more practical? Let's see how far I can get kind of quickly. And I did the cooking show thing where I pre-baked it, so I don't have any of those typical issues one might have. Let's now look at, this is a repository if anyone wants to look along. It's data-skeptic on GitHub, and it's serverless-demo-PyData 2019. You'll notice I've done a whole bunch of branches here and made myself some fake PRs. These will help kind of walk you through the steps if I go a little bit too fast, because I do want to get to our panel discussion. But let's go through it a bit manually then. Let's see what branch I'm on. Step 1, and let's open that over here and see what we've got. Oop, that's a preview for later. So in app, I didn't do too much. I thought, you know, why don't we have some sort of live shoutouts board? So I created 3 endpoints. One will just return this dictionary of whatever a shoutout is, a GET request where you could get a single one, and a POST request where you can push something to it. So let's chalice local that. And I believe in the README, I gave some little examples here. So let's post this one. I get back the response, acknowledgement true. And just to decompose this for you a little bit, let's go back to app. This is a nice way to do dynamic parameters. So I said /shout/whatever. In this case, I put my name. That will just take whatever the body is that I sent it. If it's JSON, it'll JSONify it. If it's a string, it's just going to strip it, put it in that dictionary. So that now if we go back to our, why don't I just not go in that secret mode and stay over here? Is this local? Now we listen to, okay, Kyle, listen to Data Skeptic. Great, let's see what I did in step 2. Now notice I did this hacky way of putting an object in memory. If this were a Flask app, that probably would have been fine because it's going to stay resident in memory for as long as the server's up, although of course there's no persistence here. But what about servers that go down? That's something you lose when it comes to serverless. You get no commitment about the container that it's going to run in and how fresh that will be. You can encounter things like the cold start problem that we'll get into a bit later. But for the moment, I saw, okay, step 3 wasn't good enough, or step 2 there. Let's check out step 3. And what's changed? So, oh, get checkout step 2. Already on step 2, get checkout step 3. What have I changed? Let me get checkout step 4. There we go. Here I'm introducing, let's go to my PRs. That'll tell the story a little cleaner. So the first thing I did here, let's open these in order. Put in that README so you guys would know how to access the links, and just split it out to the shoutouts idea. Okay, fun. We can post a little thing on the board. Next, I need to get that deployed, of course, to make it a real endpoint. So I set up the deploy and then switched over my README so you can see this actual live URL. I'll make it a little bigger in a bit in case anybody does want to hit it, because you'll see where I'm going next. I said, okay, this is cool, but I need to save that, because as I found out when I ran it, that object, that little shoutouts dictionary, is going to go away between Lambda runs, because of course they're very ephemeral. That's fine. I'll go ahead and latch onto DynamoDB, a popular key value store you can get in the AWS ecosystem, and there's similar stuff in every cloud. So I need to create those things. I use my favorite tool, Terraform, to set that up. So if you guys don't know Terraform, that should be the thing you learn tonight, because it's super easy and basically a modern miracle. You describe what you want. In this case, I want this table called shoutouts. I want to pay per request, have a time to live, and it's just going to be indexed on name. So I Terraform applied that. Again, we're going to do the baking show skip forward. And then I enhanced my methods so that instead of using that object I was holding in memory, I'm just doing, in this case, a table scan. Very poor practice, but good enough for our demo. Get an item, and most importantly, post that item is now to do a put item with it. Here's my Terraform file we looked at. And as my last step, I said, well, you know what? We have this goofy little gimmick. Can we take this a step further and make it into our question and answering tool for when we hit the end of the session today? We'll open up for questions. So if you skip ahead all the way to the last step, and let me check that one out. Go to here and double check. Oh, let me show you what the last step includes. Instead of just returning the data I get back from DynamoDB, I throw it into Python or into Pandas. Kind of unnecessary, but I love the Pandas 2 HTML for a quick way to spit this out. And then I'm using one of the Chalice functionalities to tell it that HTML is coming back. So let's go ahead and deploy this. I think it's deployed, but I've been messing around a lot, so let's make sure. There we are. And I could really use some testers if anybody's got a curl handy. Oh no, internal server error, what could be wrong? I really want to have our Q&A thing. Maybe I'll play with that in a minute while we're chatting. So I want to invite up to the stage my two guests. First and foremost, if you were here earlier and saw the other great serverless talk, that was a good bootstrap opportunity to get involved in serverless. If you haven't seen it, the videos are coming online. Michelle Brenner, please come to the stage. And we've got a mic floating around that'll come to you. So I'll let you introduce yourself when that shows up. Secondly, last but no least, my colleague, Alex Reeves, please come on up. Both people very experienced, hands-on with some serverless stuff, so I thought, given that I'm traditionally an interview show, we could get into some really good things around this and talk about use cases and maybe some war stories and that kind of thing. So do we have that second mic? Or I'll pass this for now while we... Why don't we pass it you guys away, give a quick intro to who you are and how you got up on stage here. There we go.
Hey everybody, I'm Alex. Been working with Kyle at Data Skeptic for about a year now. And I came out of a PhD program at UCLA in neuroscience and knew that I wanted to get into data science, but wasn't sure what exactly it was going to look like. So applying for a lot of gigs, did a few short stints, and then Kyle put an advertisement up on his show. I was listening to a lot of data science podcasts at the time to get myself in knowledgeable about the field. And things worked out, and I've had a great time working with him in the past year. And so we've done some serverless projects, and I'm excited to share any kind of takeaways that I've had using serverless with machine learning, stuff like that.
Hi, I'm Michelle. I'm actually a software engineer for the past 9 years. I have, I think, the little opposite education of you because I went to art school. And I got involved in serverless basically the last year so I could do my own infrastructure and not have to worry about pulling in other resources and kind of finish projects instead of always just doing the back end and not getting it up in the cloud.
Cool. Well, let's do a softball to get going and just say, what is it that excites you guys the most about serverless?
I can start. I can kind of expand on that. It's easier than regular infrastructure. So for me, coming from an engineering background and not a DevOps or infrastructure background, I found it an easier path to get into to build my own projects. And I love the idea of only paying for what you use. My talk, I called it the Spirit airline of what I wanted to do.
For me, serverless has also made it easy to collaborate. I was able to pretty quickly hook into a chatbot project that we've been working on quite a bit this year. So I came in with not a ton of experience in productionizing machine learning pipelines. I don't know a ton about how servers even work, to be honest, beyond what I have to write out in the configuration files. But because of awesome advances like Terraform and all the components, the serverless components that I mostly use AWS. So I'll be talking to my experience with AWS mostly here, but all the cool serverless components that AWS has made it really easy for me to build out batch jobs that build models, and we can use those models to serve inferences for our chatbots. And I was able to do that, in a couple of months of ramp up time, and now it's much easier to add new features to a project. So it's been great.
Yeah, for me, I'm actually gonna, since this part of the demo failed, looks like I'm not able to install pandas for some reason. Package download error, weird one. There's probably pandas people here who could help, but instead, I will jump into showing you guys some behind the scenes code. This is an application we use, and I'll blow this up, to actually publish the podcast and do a number of other things. This is again with the Chalice framework, and here you can see why I have fallen in love with it. I'm writing stuff that looks ostensibly like Flask code, but I get these decorators to come along with it on S3 event. So anytime an S3 object is created, this function will run. On a schedule, this function will run. On an SNS message, this one will run. And on anything put into an SQS queue, this will run. So we're able to build up this pretty cool pipeline. Let me go into our publishing tools. We have a GitHub webhook that calls this API. The answering service's job is just to write out the contents of that webhook to S3. Then that S3 thing kicks off. We go into this parse new file, which runs through a bunch of applications and basically says, do you know how to handle this? Do you know how to handle this? Do you know how to handle this? Until we get to our publishing tool that says, oh, you're a GitHub webhook? Yeah, use this parser. That parser goes and downloads the data, stores it in S3, again kicks this off and says, is it a markdown file? Is it a Jupyter notebook? Is it an R markdown file? If so, here's how you parse those and convert them into HTML, which again you save. If it's an HTML file, then we push it out to a different S3 bucket, which is the live static website. So that's just the show notes part of it. We have a whole pipeline set up in a similar serverless fashion where when we upload the MP3, it kicks off a normalization of the audio, kicks off transcription, and all these kind of great services that I don't know how we would have built it with a small team just even a few years ago without serverless. So I think that's really where my love of it comes from. Do you guys have a favorite use case, either one you've personally been involved with or one that you're aware of?
I think there's two really great use cases. One is when a service is not going to run that often. So why have a server up 24 hours a day when it's going to run once a day? So it runs, you pay for the 2 seconds and then you're done. And then the other use case is when you have a million requests. When you have a huge message queue of data you have to process. In my case, what I was working on was hitting a third-party API. I wanted to make sure it wasn't hurting, bring down my web client. As many people as make the request, as slow as the third party is, I don't want to have to worry about it. So every time there was a message, it would spin up a new serverless function. So whether I had 2 or a million, it could handle it. So those kind of ends. And then if you have just like a normal path of not very high traffic, that's where you should just have like a regular EC2 server up.
Yeah, I think I also have enjoyed kind of the batch job part of it the most is spin up a big EC2 instance, for example, and then, do a heavy workload and then just expect it to be spun down on its own after it's done.
Maybe you should go into what batch is. I bet not everyone here knows about that service.
Maybe they don't. So one of the great things, right? So AWS is kind of maybe godfather of serverless, and they the poster child of their serverless services is like Lambda, which is functions as a service, right? You write a function and then it manages running that function for you. But some of the limitations of Lambda are that it's got low. You have limited execution time running a Lambda, and then you have limited compute resources when running a Lambda too. I don't know the details of why they have it set up that way. That's just how Amazon has decided to manage their Lambda functions. But they do have another service called Amazon Batch, and with that you have, I'm not even sure if there is an execution runtime limit, and you have access to much larger compute resources. So you can, like the use case that I'm talking about here, building machine learning models with AWS Batch, I mean, they handle, allocating all those compute resources for you so that you have a big machine that could load like a large language model like BERT. It was the use case that we had. And then do all kinds of like retrieving embeddings from BERT and then using those embeddings to build a model off of. They also handle like the orchestration of it. So if you want multiple jobs happening where, yes, you want to build one model one way, but you give some other parameters to build the model a different way for another job, they can scale that way up, and you're still able to allocate like large resource jobs or large compute resources for these heavy workloads. So it's been a little bit of a learning curve at first, figuring out, how it is, there's a queue that AWS manages to get like all the jobs lined up for you to say, okay, now it's this job's turn to run on this compute environment. And so it takes a little bit of time getting used to, but once you have that, it's great. Pretty much anytime you're running a cron job, you could just turn that into an AWS batch job. And so there's lots of use cases for it.
Sorry, I sent you on a tangent with my sub-question. I was asking about favorite use cases. Okay, you gave us some. So let me, I don't know if I have one. I guess I'm going to have to pick our publishing system, because how cool is it that the whole podcast runs serverless, especially the audio pipeline, which we're just kind of finishing up these last couple weeks. Alex, you touched on some of the limitations of serverless. Maybe we could spin off of that. Are there situations in which you guys would recommend against adoption of serverless? Any types of projects that's not a good fit or maybe not the ideal tool?
I mean, there is some overhead associated with setting up a serverless project. So I think a one-off analysis, you don't want to do serverless. Like Michelle was saying, you made a good point about how, like, if the demand loads are predictable and consistent, then maybe you don't need the serverless where it all gets managed. I don't mean to step on.
No, that's exactly what I was going to say. It's best for like the things you need to run not that often, and the things that need to run at huge scale. Otherwise, it's actually just cheaper to have a regular server up that's fielding requests. Because there is one thing I want to mention. There's like, we all like to talk about how it's like, oh, it's just writing the function, but like there's such a huge learning curve for this. So that's why I said in my talk like 400 times, you'll get through it. And once you build it, updating it is so much easier. And once you have that infrastructure in place, and once you kind of understand all the moving parts, I like it because it's someone else has done the work for you in a lot of different ways. You can basically find an Amazon service to do anything. And if you can't find it, you can complain and they'll probably write it.
Yeah, there are limits to serverless that are, I think, when you get extremely technical. So in a way, they're almost uninformative, because if you don't worry about latency and network lag and cold starts of Docker containers, then you're probably developing something that isn't, a medical application, isn't mission critical, and whether or not those are even relevant issues for you is questionable. I feel like you kind of have to know about the problems with serverless to even bump into them. But the best example I can think of, there's an interview on Software Engineering Daily where Jeff's talking to somebody from like a sporting video company. I forget what it is, but the problem they have is that sporting events tend to be like live focused, so their traffic all shows up at exactly the same time, and that is a really bad use case for Lambda because there are concurrency limitations. If you have your own pool of servers, I mean, hopefully the pool's big enough, but you kind of manage it and it's hot and ready all the time. The cloud providers have the sort of no particular guarantees. I suppose there's some SLA somewhere, but there's no real guarantee that your code won't have a little lag every so often. In fact, if your code doesn't run often, they may spin down the hot container they have behind the scenes to run it and put it like in some sort of cold storage, and the next time it's required, has to defrost before it's ready. I have experienced that, but it's the kind of thing like where, all right, you go to talk to our chat bot and it lags for like 3 seconds on the first message. you're probably going to blame your cell phone provider, not us. So, and if it were a big issue, I guess I'd ping it constantly, and that'd probably suit us. But that like burst of concurrency is an issue, but also probably the kind that the AWS people would want to help you with because it improves their product. Which actually brings me to a good point. I have seen massive improvements in the tooling and technology around serverless in just the last year. What about you guys?
There's new things that come out all the time, and I can tell it's new because I can't figure out how to use it, basically. Like the newest thing that came out was Lambda layers, which is a way to reuse your code so you're not, always putting new code in your Lambdas, and I still haven't gotten it to work. But it'll get there. And one thing that actually came out at re:Invent this week is that cold boot problem, they have a solution for it. So, yeah.
There we have it.
So that's exciting.
Yeah, and with the cold start problem, you see that with the AWS batch service too, but I think it has to do with just having to assemble all those compute resources, and they call it batch for a reason, it's like they want you, it's intended to be a batch job kind of process. So
yeah, if I'm going to train a model for an hour, I can wait 30 seconds to spin up. So besides the kind of vanilla use cases, the image thumbnailing I'd mentioned, maybe moving around files or something, what are some of the more novel use cases you think might surprise people, or areas you're thinking about applying serverless?
I can start. I've been really impressed with some of the stuff coming out of Google Magenta, just for some personal projects. So I'm
fill that in though, so people know what that is.
So I'm into music. I'm not a musician, but it's definitely a big hobby of mine. And Magenta is this project at Google that's main focus is to look at the intersection between AI and art and see, what can AI offer artists. A lot of the projects end up revolving around music. There's some other stuff about graphic design and drawing that I haven't looked into as much, but it seems really cool. And with Magenta's music stuff in particular, there's this model that they've got for transcribing piano music into MIDI. I don't know if you guys know what MIDI is, but it's like a file format for representing musical notes. And what I think is so awesome about that is that it can take years and years of rigorous study to be able to transcribe piano music into music notes. But this model that they've got, onsets and frames, I think, has a really great accuracy for turning music into piano music into MIDI. So it's piano specific. They trained this model basically on this data set of piano competitions. So they've got like gigabytes and gigabytes of audio data that correspond perfectly with a MIDI file that represents the performance of that audio file. And so they use that to train the model to be able to translate audio into MIDI. And so I thought that was so cool because the accuracy is great. I turned that into basically a Python script and a Docker file. So I don't know how much familiarity people have with Docker, but it's basically a way to like reproducibly run compute jobs. So like in my case, it's like running this Python script that loads a machine learning model to translate audio into MIDI. And I put that into AWS batch job, basically. So I have the Docker image running in AWS batch, and I can send it a audio file, and then later in S3 it deposits a MIDI file for me. And it'd be fun to one day kind of open that up to other people so that they can take advantage of this really cool machine learning model to turn like audio into MIDI. So
neat.
Yeah.
So security and compliance. I don't know if anyone has ever had to work on something that require compliance, like PCI, which is credit card compliance, or in healthcare, where you have to be very careful how you store data and who has access to that data and how you can deploy code and how you can access that database. By segregating the code that requires compliance, it makes compliance so much easier. So if I just create one microservice that all it does is the credit card processing, that's the only serverless microservice that have to be compliant and no one can touch. Another part of that is using Amazon's encryption. It's very easy. So anyone who is storing credit card numbers in plain text, you're just like the laziest person on earth, because it's literally like dot encrypt, dot decrypt, because it's all in the service already. So all the keys are stored together in your one account, and you don't have to worry about moving all those parts around. So it makes that step much easier. And then you could be all those services that don't touch that secure data or that secure code, you can just go wild on, and all your developers can deploy because you're not worried about losing someone's data.
Yeah, there's a lot of like old man things I bump into. I call it that when I'm like back in my day kind of stuff. So much about like, how do developers get their own environment? Doesn't run the same on my machine. These are like antique problems at this point with modern frameworks and stuff, I think. I like your idea of security and compliance. There's, to me, in my mind, two layers of serverless, sort of like the children and the adults almost. Like the basic stuff being that make a thumbnail of an image, really useful, quick, simple things. And then there's like serverless application development, which is like orchestrating microservices together, which is partially why I like this Chalice example, that I have all these, this is a bunch of Lambda functions when it gets deployed, but I wrote it as if it were a traditional software application. But more than that, I'm going to kind of philosophize for a moment and share some thoughts I've had about this. The way I design now when we do serverless really centralizes around a queuing mechanism. So you'll notice we're listening for queue events here, and we do something called process work, which takes a very generic event and is a short bit of code. Why? Well, because I want to write really, really tight unit tests against this process event function so that I'm not worried about like, oh, I deployed it and some weird thing happened or the format's different. I want to have the most minor of a difference between the way Lambda's going to run it and the way I run it locally. But also, if I'm just putting everything on this queue, or better yet, like an SNS topic or a Kinesis stream, then you can always have Lambda functions attached to that. They do so really easily. And anybody can latch onto that. So even though I've never had this happen yet, I have this promise I make a lot of clients is like, oh, we'll just put stuff on here. And when your billing wants to look at it, they can just listen to events and aggregate them. And if some fraud detection engineers come around who are really, really smart at fraud, if you have a good event stream, they don't need to learn your custom schema. They can just go sniff those events and grab a chunk of the data and start training models even in real time with some of the tools that are coming out. So I think event-driven programming is almost hand in hand for serverless with me. How do you guys feel about it?
Yeah, I do both. I have endpoint based, and then I use it a lot for cron tasks
Yeah.
because it's such a great, like something I need to run once a week. I just set up an event bridge task, and it just runs the Lambda, and then I don't have to worry about it, which is nice because just running that little bit of code, and I don't have to put it on a server. It'll just be done when it's done.
For me, I'm still kind of getting used to the whole event-driven programming paradigm, to be perfectly frank. But it's interesting. What I have trouble getting used to is like it's basically all comes down to sending messages. So
Yep.
it's I guess I get the gist of it, but I don't have a firm grasp on how the whole philosophy works. So
I think it's because you came straight to work for us out of academia. If you'd been at a big company, you'd know this policy called "not my job," which is the best way I like to think about event-driven. It's like you see an event, you say, someone else should do this to it. And it's just this kind of chain of transformations, and they're auditable and all that kind of stuff.
One of the things that comes up a lot in in queuing is like the slow queue and the fast queue, and you always want to separate all those tasks, right? You need separate queues for your emails than your image processing, or your, if you're processing large amounts of just data on the back end or videos like that, you can put that in the slow queue. And by having this serverless, you can break them all up. So
people have been stretching the definition of what serverless means almost to the point where sometimes I'm like, come on, really? That's okay, yeah. Do you guys have any services that have stuck out in your mind, or are you waiting for a serverless service to appear? I'm thinking of things like Athena. I think SageMaker claims to be serverless, not sure. What else? But Batch is also a good example. Like, how is running a container serverless? How do you guys feel about the sort of abuse of this word?
I would say I'm not waiting as much for technology as much as I'm waiting for tutorials. Like there's so many use cases for it, and I'm often finding that I will get like, here's all the flags you can use, but no explanation of how to actually use it. And I just want all those use cases because I think there's just so much creativity that we haven't tapped into or documented, or because maybe people are using it in these cool ways and I just can't figure it out. And I feel like use Terraform, I use CloudFormation, they're basically the same thing.
Yeah.
And they're just maddening because you'll find different syntax in CloudFormation versus the console versus the command line. And I want that more than I want new features, just like fix what you have.
Yeah, that's fair. Let's see. So along those lines, we have shown, Alex and I, our AWS bias, not because we're shills, but because we just sort of, that's what we work on for the most part. I was really glad, Michelle, in your talk to hear how agnostic you were and some of the trials and tribulations of being serverless on the big three platforms. Can you share maybe some summary of your talk that people can watch later, or just some lessons from the field about what was easiest and most difficult?
So Amazon obviously has most of the market share. They have most of the products. So it's kind of easier to step into, except they're also locked into this legacy design, which Microsoft and Google kind of took that design and was like, oh, let's make it easier and better. So they've been able to learn some lessons, which is nice. But since so many less people use it, you'll find less documentation. There's a little less support. But Google is the only company that responded to a support ticket. So I always like to say that and shame Microsoft and Amazon for not responding to me for weeks.
I would love that to become its own project. I think we should form like a union of developers and shame the clouds that don't. Yeah, something like that'd be good.
I've actually given this talk, and I didn't realize that these developers were in the room, and I've got taken back and be like, oh, it's worse than you think. Like, it's more complicated. Like, you missed some parts that were like more confusing than you ran into, and it's hard to keep up with the pace of development and make that documentation better. And I wish they would just slow down. And like, my dream feature is to have in the console a button that you can just click and it'll give you the command line and the CloudFormation version of what you just did. Because I feel like I spent so much time trying to figure out what that is. Yeah.
Can you patent that some kind of way? Are we still doing patents?
I've pitched it to like everyone in the company, and I'm just like, just be Postman. Like, Postman does it. Why can't you?
Yeah, that's a good model for sure. I personally feel it's a bit like the journey we were on with big data, beginning kind of with breakthrough technologies like Hadoop, which were wonderful and that they worked, but terrible and that you had to use them, and evolved into stuff like Spark and even like Spark SQL. I mean, now you don't have to know anything about distributed computing to just write SQL queries and you can do big data stuff. I think we're getting there with serverless. Where are we on the journey? How long before people who, don't want to bang their heads against the wall every day are comfortable saying these are mature toolings?
For me, it's about non-legacy people being able to use it, right? Mm-hmm. So I would always see this documentation that'd be like, they would use A as an example to explain B, but I don't know what A is, so none of this helps me because they assumed I already had that domain knowledge of a system administrator or someone who built infrastructure. So I think when it starts to become so easy that anyone can just spin up their own tools, like, the tools are so powerful. I just want to tell people who aren't even engineers, who want to start businesses, like, I want you to be able to use this. If only the documentation was a little better, then you could get it. So I feel like once the companies realize if they make visual versions of what they're doing and make it actually production ready, then it'll just explode and anyone will be able to very quickly bring their apps to life, which is like my dream. Anyone who's, has barely written any code to just dream big.
Very cool. I think we all have our own war stories about the simple task that took 3 days. We see these demos like the one I've failed to complete here, where it's like, hey, in 10 minutes you have stuff up. And indeed, we did get the Hello World up. We just couldn't get my Dynamo installed, I think probably because of a Wi-Fi issue. But nonetheless, I'm sure you've had painful experiences. Are comfortable sharing any and some lessons learned? I've got more than my fair share if you guys don't.
Yeah, no, I've definitely had my share of difficult experiences. With Terraform, there's a learning curve because a lot of times, for me, it's just a big configuration file, basically, is what Terraform is, or CloudFormation, I guess, in that case. And understanding what these configuration settings mean can be a bit overwhelming at first, especially if there's a lot of interconnected parts. And my kind of tip for dealing with that overwhelming amount of infrastructure is to mess around with the UI or the console a bit, and any tutorials that they have, because for me it makes a huge difference to kind of picture what I'm doing when I'm writing out these configurations and saying, okay, I want a EC2 instance of this size, and I want I want there to be an execution time limit of this amount for the Lambda function, and so just getting a sense for like a big picture of what each component can do and how it interconnects with other components in the ecosystem was really tough using just a configuration file. UI helps with that.
I'm gonna build on that and talk about permissions. They're the worst.
Yeah.
I think it's a lot of my walls I ran into was just not understanding the design and what the intention was. And once I kind of wrapped my mind around that, I got it. So every service you use, so Lambda is the function, and then DynamoDB is the database. They both need permission to talk to each other. And in real life, it doesn't make any sense, right? Like, it's like we're coworkers, and I have to like give him a passcode to chat with him. It's like, that doesn't make any sense. We sit right next to each other. But once you realize that, it's just one of those barriers where it's like, okay, I need to make sure every service has the permission it needs. And just doing things one at a time, I think, is really helpful. Like, don't try to plan your entire service. Like, just get the database and deploy it and see if it deploys. And then add on the Lambda on top of it, and then add on the encryption. And just once I got into that rhythm of one at a time, because you might have to deploy it 20 times to get that database to work, to get that syntax exactly correct. But when you have like 7 things, you'll never figure it out because the error messages can be obtuse. So if you've only changed one thing, like, well, at least I've limited the area that I've messed up.
Yeah, I think for me, I bumped into a lot of problems where things would, the works on my computer kind of situation, which is exacerbated by the fact that the cloud is not your local computer, especially when it comes to permissions. So we can write a fun little line like, let's scroll up in here, import Boto3, and then, where am I using some Boto3? Do you guys do Boto or Boto? What's the consensus here? Hands up for Boto. Oh man, okay, I guess we'll do Boto today. Oh wait, hands up for Boto. Jeez. All right, Boto3.client. As you guys know, this is grabbing from my .aws/credentials, at least on Mac and Linux. Works great locally because I have a fairly generous IAM key in my development thing. When you deploy this, you are going to get the role of the Lambda that's assigned, which is totally configurable, but a little bit obtuse. Chalice tries to take care of that for you. It does generally a good job, but there's one weird trick, and this is a trick that all of you will owe me about 8 hours of your time after I teach you this. Chalice begins by declaring a Chalice app like this, And if you want this to kind of realize that you're going to use AWS services that you'd like it to provision a role for, then you have to explicitly call them afterwards. So if up here I had said something like, S3 client is boto3.client S3, you would not get the S3 permissions. Which is sort of not intuitive at all, but moving it down here, suddenly something with the compiler, I don't know, I didn't look under the hood, but you get that to work then, because the app can see it and it will provision that for you. But figuring that out on your own is just not elegant today. It's one of those things where I think it'll become elegant. Things are getting better. When we started, there was no auto provisioning of the role. So at least we have that. Maybe it could just provision itself a little better. But all things in time, I suppose.
I just have one fun story. You can make things that you can't delete, which I realized.
Really?
KMS keys, you can provision them and then realize that you didn't give yourself permission to edit them, and then you can't delete them. Like, you literally have to give root permission to edit them. And I was just like, team, this costs $1 a month. I don't know how to delete it. I guess it's there forever. I don't know. But those are just the fun things that happen when you don't realize that nothing is automatic. You don't automatically get permission to do that.
Yeah. Although I have to say, with as much as we've kind of complained, I have seen a generally monotonically increasing improvement in the tooling and stuff. I can't think of a big step back that I was mad about, which is atypical. I usually am mad about something in a new version. So that might be a good sign. Are you guys building anything interesting at the moment in a serverless fashion? Alex, I know you are.
Well, let's see.
You can talk about ID images if you want.
ID images, okay. Yeah. So with that, it's been an interesting project where we're leveraging some of the event-driven programming that we're doing with Chalice, and what we've got going on is a system where we want to turn images of nutritional labels, so what you would see on the side of a cereal box, and determine whether those labels are in compliance with FDA regulations. So there's a lot of regulations. It's a big, long document with different things to consider about font types, relative font sizes, and things of that nature. And we want to automate as much of that as possible. So we're using Amazon Textract. I don't know if you guys have heard of this service, to, in a serverless way, collect extracted text from all these nutritional labels, and check features about relative font sizes, what kind of wording is used in order to determine whether nutrition labels are in compliance. And without Textract, OCR is
That's what Textract does, right?
yeah,
OCR.
it's OCR, and it's an essential technology. And then making it kind of a managed service by AWS really kind of makes it easy to do at scale. So that's been a fun project. Yeah.
So I talked a little bit of how I use it in production a lot, doing third-party APIs and compliance, but you could also use it for very silly things. So I want to tell the story of what happened this Thanksgiving. My sister came to visit me, and we both realized that our parents forgot to contact us on Thanksgiving and send us nothing. And we're like, whoa, not even a text message from them. So instead, I decided to make a parental approval bot with Twilio and serverless that will send me aspirational messages like, I'm actually proud of you. Please, I remembered your birthday. Please tell me about your life. And you can pretend that's from your parents. And it's just the nice thing about it's a nice part of serverless is it's once you get the hang of it, you can make templates, and it's easy to spin up nonsense projects for yourself and
Absolutely.
to make fun of my parents.
Yeah. Well, you hit on an interesting point as well. I keep thinking about my life. I have a graveyard of interesting little projects that worked, and then some servers no longer up or whatever. Serverless is kind of forever, and you pay basically zero. So if you have some little project, if it gets popular, you'll be paying for it, but that's kind of a good problem to have, right? So it's a neat way that I think as developers will have more permanence of the things we build. So maybe we need to build them better so they really represent who we are and what we're trying to do with our careers and whatnot. We haven't touched at all really on Python. Of course, serverless is available in almost every language, and let's just say every language because that's where things are headed. But Python, as far as I understand, remains the most popular deployment. Why do you guys suppose that is?
Python is easy compared to
Yeah.
other languages. It's also for people who are planning to create quick things. I think Python
Yeah.
is like a go-to language because you can script in it. If you're creating more enterprise projects, you're using something like .NET. You're less likely to be able to move to the new technologies. So I think that's why I think Python is up there and why I like using it.
Yeah, I mean, there's. I don't have a strong opinion about this, but it seems like Python is a go-to language, one of the go-to languages for like IT and server administration stuff. So it seems like you want to be able to support that kind of language when it comes to building serverless applications, serverless infrastructures.
Yeah, for me, it's the complaints I used to have about Python, by the way, most of which kind of got resolved with Python 3. I'm glad that you have optional typing and things like that now, even though it's fake typing, it's there and it basically does what I want it to. All those like criticisms of this will be hard to manage if it gets to 1 million lines of code because there isn't hard compile time checking the way you get in TypeScript or Java. Those problems kind of don't matter in the serverless world because your code is supposed to do a simple thing and be done. And if anything, you're just going to chain a bunch of simple things together, which also gets back to kind of event-driven, what I think is a healthy coding style. Why don't we pull up another code example? This is mine, so I can show it. In the podcast, for example, blog update request. Oh, that's a work in progress. Let's see. Yeah, so like we have just an add a blog function. All I need is a title, an abstract, a year, and the slug, which is what we call the sort of root file that came over from GitHub, which we use as a CMS. And this is one line of code that just has to get triggered by the function. And if I make some change, I want to introduce some new property or something, it's not a big deal that some object is not expected and I forgot something. Plus I can unit test the heck out of this and just this function. And even though Python doesn't necessarily have its claim to fame isn't necessarily its elegant unit testing. It does the job for me for sure. And just the ability to write very declarative, simple, short code and also import really powerful libraries is, I think, why it's kind of the leader, at least why I choose it for most things. Have you guys seen any, actually I want to ask about legacy systems. There are sometimes motivations to maintain a legacy system and other times to reinvent. Do you have any thoughts or best practices on how to answer a question like that if a software organization is dealing with some rather monolithic system that does happen to run? How do they know if a serverless migration would be right for them?
I've actually worked on this type of project. So just peel off something and try it. That's basically what we did. We're just like, okay, let's try one thing that we do in our giant monorepo as a small thing. You do that, or, oh, I have this new feature. I don't want to touch this monster. Let's make it completely separate as its own thing and see if it interacts well, and you can slowly change it. Or you could just leave it alone and just add all new things as microservices. But when, everyone knows the problem of legacy systems, right? The more people who work on it over time, the harder it is going to get to work with. So that's the whole push to those microservices where you're less likely to have two developers working on the same file or all the developers leaving and no one knowing how to use it.
Mm-hmm.
At least with microservices, it's a very planned execution. So I think you can definitely do it, and there's many ways to do it, and you might as well try it. And if it doesn't work, then you leave it the way it is. Yeah.
I think you hit on a key point. It's if you're going to adapt a microservice architecture, which if you're not, you kind of almost have to justify that anymore. But if you are, it lends very nicely to serverless.
And it's just really nice with the serverless, you can push a lot of that burden onto the engineer and make them deploy it themselves, and
Yeah.
and they'll learn something and they'll be able to handle the whole system and kind of be more responsible for the whole pipeline.
Yeah. And if I may be so bold, I think it'll become almost a de facto standard. I imagine engineers working in businesses around the turn of the century might have had to worry about the electrical system staying up. I don't know of any business, at least in the US, that worries that the electric is going to be on. You just take that for granted. And I think some of the services like these functions will scale infinitely and all that kind of stuff can be taken for granted. So we're getting to the end. I want to save a few minutes for questions if there are any. I don't know if there's extra mics. We've got this one here we can pass, and then everybody on stage can share this one. So I'll run that down.
So my question is to Michelle. You mentioned earlier in one of your responses that a good way to try to build out your entire framework is to take one thing at a time. And I agree, it is easier to diagnose problems that way. So I guess like as you came up your own learning curve, did you find yourself as you were layering one service on at a time or chaining them together that you Frankenstein something that was really hard to undo?
No, because it was kind of, I had an idea of the big picture. I used a chart first, right? Like I draw everything out. I like use Lucid chart to know exactly where I wanted to go. And then I kind of just did one service at a time until it all worked. And the first time I did it, I was like, oh, this is an easy template. I'll just fill it all in with my names and it'll work. And it didn't work. And that's when I realized I had to comment most of it out and try things one at a time. And that's kind of where I realized, okay, this is too complex to do all at once. And I'll just add one service at a time until, I checked them off on my little chart as I added them in.
I was wondering if you guys could talk a little bit more about like your troubleshooting steps when you have an application that's working and then something goes wrong within a serverless environment.
Sentry is your friend. It was really easy to set up and has great diagnostic tools. They should pay me because I keep talking about them. But also just, you can use all the same logging tools that you normally like to use and just kind of plug it in and see your tracebacks and see your monitoring. So it's less about the tools and more about planning on what you want to check. So if your serverless is always making thumbnails, you can have something that checks on if those thumbnails stop happening. So it's kind of the same observability and metrics you do with any system, except you don't need to do a heartbeat for the server. You're more looking for that the output that you expected is happening all the time.
Yeah, I have struggled with this, so I'll give some personal advice of what worked for me. I've focused very heavily on the actual like serverless Lambda-ish parts, like the function that the cloud provider is going to actually call, to have as few lines of code as possible and be some just wrapper function. Because the back and forth of deploy your code, test it is kind of a really bad time sink. You end up with these horrible iteration times where it's like 5 minutes for a line of code change. So the more I can unit test and do things locally and allow just like one possible point of failure, then I can also try accept that in an ideal way, log it however I want. But out of box, you will bump into some problems there. Logging is not super elegant and mature the way it is for a lot of other systems. Yet.
So for the serverless part, I found that just using the AWS console to debug Lambda functions is actually pretty, speeds up the iterations. So that's been useful. And then this is more ECS, EC2 stuff, so not exactly serverless, but I've always found that it's like really worth it, especially if you've got like a development AWS account where you're building stuff out in, to give all your EC2s SSH keys. That way you can SSH into them and see, get even more visibility into what kind of problems your serverless or cloud application is having.
Well, if we solved all the problems tonight, we can wrap a minute early. I'll certainly stick around to chat. I don't know if you guys are. It's been a long day for all of us, I think. But thanks, everybody, for coming. And if you're interested in doing serverless stuff or just having a conversation about this, it's something we're actively engaged in, eager to engage in. And imagine the same for you, Michelle. So hit us up for sure, social media and all that. We'll pass it around. You could find me at Data Skeptic on Twitter and Data Skeptic Podcast.
You can find me on LinkedIn, and then you can reach out to me, email alex@dataskeptic.com. Those would be the two main ways.
You can find me on Twitter at Michelle Lynn B. And also, you should listen to my podcast called From the Source, where I interview working professionals in tech, and we talk about the good, the bad, and the boring of their tech jobs and how to get there.
Awesome. Well, thank you both so much for coming out. Round of applause for these guys, everybody.